Hi, everyone. Thanks so much for coming. My name is Emily Woods. I'm a board member with the Glendale Environmental Coalition. So the way it's going to work tonight, as you've noticed, you are muted and you have your cameras off, and that is to help preserve bandwidth and just to keep things running smoothly. So for the Q&A portion, please message me in the chat. Click chat, new chat, search by name, and then put in Emily Woods. So we have two speakers tonight. First up is Michael Rockmas, the Policy and Advocacy Coordinator for the U.S. Green Building Council California, and then Brett Markey, who is co-owner of Hilo Air. And after their presentations, we will do the Q&A. So yes, again, just send me your questions throughout, and I will read them out after the presentations. Michael, I'm going to turn things over to you.
Great, thank you. Let me get my slides up. Thank you, Emily, and everyone at the Glendale Environmental Coalition for inviting me to speak today. Um, like Emily said, my name is Michael Rockmus. I'm the Policy Advocacy Coordinator at USGBC California. For those of you who aren't familiar with us, the U.S. Green Building Council California is an independent, member-based nonprofit across the state of California with the mission of transforming California through the built environment into a more sustainable, resilient, and equitable place for all. And of course, I'm here today to talk about the air conditioner to heat pump reach code that recently passed in Glendale, also sometimes referred to as AC to HP. So I want us to take a step back and just start by explaining what a reach code is. So a reach code is a local policy that amends the state building code. The state building code is kind of the baseline code that it regulates new construction and renovations across the state of California. It's updated every 3 years. The latest version is going to go into effect on January 1st, 2026. And the state also it's a leader in terms of having a strong building code, but it also encourages local cities and counties to pass their own reach codes that go beyond the state code. And an energy-based reach code has to be both more cost effective and it has to increase efficiency. So it has to be stronger than the state code. And then what are heat pumps? So heat pumps are essentially a bidirectional air conditioner. They're like a conventional one-way air conditioner with the addition of a reversing valve, which means that the installation is very similar. The manufacturing is very similar. They're same size factor, same electrical requirements. Um, and Brett knows way more about that than I do, so he will get more into the details on that. Um, One of the good things about them is they are more expensive up front, but with incentives, they're generally less expensive than a conventional air conditioner. And they have twice the value. They provide cooling and heating. Um, and there's long-term savings when you get a heat pump instead of an air conditioner. You then don't need to worry about getting a new furnace when your furnace breaks. So when we put this together, an AC to heat pump reach code is a local requirement that most new or replacement central ACs are going to be heat pumps. There's we'll get into some more of the detail of when it doesn't have to be a heat pump. The AC to heat to HP reach codes can be for single family and also for non-residential. In the case of Glendale, it's only for single family. I love this quote. This is from a podcast where it's really HVAC installers kind of talking to each other. And one of them, this guy, Nate Adams, he says, he's talking about heat pumps versus conventional air conditioners. He says the easiest way to describe it is it's like two Toyota Camrys, one that has a reverse gear and one that doesn't. And otherwise, they're identical. And do you really want a car without a reverse gear? And then the other host says, if it was a car, that would be a lemon. and you would sue Toyota for selling it to you, but we accept it in air conditioners. So basically, the point is that the difference between a heat pump and an air conditioner is such a simple piece of equipment that allows it to switch directions and both heat and cool. And it's silly to kind of get one without the other. So, getting into a little bit more detail of how this works for a Glendale resident. So, it applies to existing single family homes, duplexes, and townhomes. Any other type of a building is not covered by this policy. And it comes into place when you're installing a new central air conditioner. It could be as a replacement, or it could be for a home that didn't have AC previously. Um, but it's not requiring anybody to take out their existing air conditioner. It's just when it's time for a new one, anyways. So what it requires is you either install a heat pump instead of a conventional AC, or you get that conventional AC, but you do some alternative efficiency measures, such as higher rated insulation. Um, and what do you do with your existing furnace? Most people probably will remove their existing furnace. I'm curious to hear what Brett will say about that. But you are allowed to, under the policy, keep your existing furnace, it could be gas or electric, um, as backup heating only. So it only is supposed to come on when the temperature dips below freezing outside, which is pretty rare, right, in Glendale. How is this enforced? It's going to be through the permit application process. So if you go to get a permit for conventional AC, then they're going to explain this policy to you and give you your options. Um, and there is an important exception to note, which is if an electrical panel upgrade is necessary for a heat pump, but not for that new AC that you otherwise would be getting, then the policy does not apply. A lot of people are worried about um, panel upgrades because panel upgrades are time intensive, expensive, right? The good thing is you never should need it with a heat pump compared to an AC because the electrical needs are going to be the same. But in the policy, they have this, so you can kind of rest assured, that you have this option. So let's talk about cost because I think the two most important things for most people are does it work well and how expensive is it? So in terms of installation, there's been studies done and they've shown that on average, a heat pump compared to a conventional air conditioner is about $2,000 more for that heat pump to purchase it and install it. Um, but that's before incentives. And there's a lot of incentives out there. I'll go into a little bit more detail on the next slide. But just with Glendale Water and Power, you can get up to $5,000 for a heat pump, depending on the size of the equipment. And then you can stack other ones on top of that. In terms of operational costs, people are worried because electric rates are really high in California, which is true, and that's not great. I would love for electric rates to be a lot lower. Um, the good news is that heat pumps are much more efficient than other systems, other alternatives. So during the summer months, if you're going to get an AC or you're going to get a heat pump, if the efficiency rating's the same, then you're going to have the same efficiency. It's going to use the same electricity. So it's not going to cost any more. In terms of during the winter months, if you're replacing an old electric heater with a heat pump, you're going to save a lot of money because the heat pump's way more efficient and they're both using electricity. If you switch from gas to electricity, the efficiency benefits of a heat pump kind of are um, wiped out by the cost difference between electricity and gas. So it's going to cost about the same. It might cost a little bit more in the first year in terms of the overall utility costs, but over time, the gas costs are projected to go up more quickly than electricity costs. And so by the end of it, you're going to be saving money on your utility bills as well. But even in the short term, the studies show it's usually not a big increase. And then in terms of your like lifetime savings, you're going to save significantly by avoiding the need to replace your furnace. So if your furnace and your AC broke at the same time, getting a heat pump is completely a no-brainer. But if your furnace is still working, um, you might it might break in 5 years, and now you don't have to replace it. So that's a big benefit. Here's a bit more about the incentives that are available. So Glendale Water and Power, and I mentioned that's up to $5,000. That's based on it's per ton, and ton is essentially the power or the size of the system. My understanding is a conventional kind of single family home is probably like 3 tons, maybe 4 tons. So that's like $3,000 to $4,000 right there. And I mentioned it's $2,000 more upfront. So you're already saving money by going with the heat pump. It does all of these. They have to be Energy Star rated heat pump, which means they're going to be more efficient than other equipment. Like it's not the least efficient that are on the market. It has to meet a certain efficiency level to be Energy Star rating. And those typically do cost a little bit more. But again, these incentives can be stacked. So you can get your Glendale Water and Power incentive. You can also get your statewide Tech Clean California incentive, which is $1,000 to $1,500 for kind of average income or upper income. And then for lower income, it's you get an additional 2,500. Those incentives you have to get through the installer. The installer has to be kind of set up to get those for you, and they have to apply for them. And then there's the South Coast AQMD Go Zero program, which is a pilot currently, but there's a lot more funding. They're expecting to kind of expand it. It's new. They still do have money in it right now is for single family homes. 1,500 for most people. And then if you live in an overburdened community, which does include some of Glendale, it's up to $3,000. So you could easily get $5,000 to $10,000 or more through these. And that's not even counting the federal tax credit, which I wouldn't really count because it's about to go away. But just so you know, it's like there right now. And I think I got the numbers on that right, but I kind of did it from memory. The last thing to note on this is that some of these programs require you to decommission your old gas furnace. So technically, you can keep your gas furnace, and some people might like the idea of keeping their gas furnace because they think there's a power outage. I want the gas furnace as a backup. Um, a lot of the incentives are set up currently. They don't allow that. So something to keep in mind. Okay. So, kind of some of the benefits of this policy. I talked about affordability. I really do think there's um, like a consumer protection aspect to this policy because you're getting better equipment, twice the value. You don't have to replace your furnace later, and it's basically similar upfront costs once you consider incentives. Um, but then there's all these other benefits. So environmental. A properly installed heat pump is going, even if you keep your gas furnace for backup on those freezing nights, it's going to cut your emissions, or sorry, it's going to cut your gas use by about 90% or more. And what that means is you're going to have less indoor air pollution and outdoor air pollution. You're going to basically seriously reduce the risk of carbon monoxide poisoning because carbon monoxide poisoning happens when a gas appliance is not working correctly and it causes carbon monoxide in your to kind of leak out. Um, and that doesn't happen with electrical equipment. So and it kills hundreds of people every year in America. And then carbon emissions. So one of the, things people say is like, well, the electric grid is using gas actually. So you're kind of using gas when you use electric appliance. Right now, Glendale's power is about 50% zero emission, right? And the other 50% is dirty. But it's going to get cleaner every year. So your electric appliance you install today, every single year is going to have less and less and less greenhouse gas emissions associated with it, versus a gas appliance is going to use the exact same amount every single year. So you're just locking in all that greenhouse gas emissions. Okay, so this is my last slide. So Glendale is not the first city to do it. It's the first city in LA County. So Glendale should be applauded for taking leadership there. But there's about a dozen across the state that have AC to heat pump breach codes right now. And we're trying to recruit more cities to do this. It's a pretty kind of new idea. Um, and so if any of you are not Glendale residents and you're just curious about this policy and think it would make sense for where you live, I would love to have you reach out to me. I'll put my email in the chat later, but it's michael@usgbc-ca.org. And yeah, I would love to work with all of you to encourage other cities to consider this AC to heat pump breach code. So thank you. I'm looking forward to Brett's presentation and the discussion to follow.
Awesome. Thank you, Michael. And thank you guys for having me here today. So, as he said, or as they said, my name is Brett Markey. I'm with Hilo Air. We're an installing contractor in LA County, and I was asked to come give you guys a little bit more information about what heat pumps are, what they aren't, what to look for yourself, what the contractor is going to look for, especially when deciding if a heat pump is right for you. The differences in energy usage, and just a general overview of what a heat pump is. So, as Michael mentioned, a heat pump is an air conditioner that works in reverse. So, for replacing a AC with a heat pump, you will see no difference in the way your air conditioning works. You will see no difference in your electricity consumption from a straight heat pump to from a straight AC to a heat pump. The difference, as he said, is going to be in the heating side. So instead of using gas to burn inside your home, you are going to use electricity and an air conditioner working in reverse. And with the technology that's happening right now, and to speak on that, from here on out, all of the better technology, everything that's going to be making them more efficient and more comfortable to use is going to be put into heat pumps. California is leading this, but the rest of the nation is behind, and they will be putting this kind of code everywhere across the nation. So all of their resources are going to go into making these more efficient, and having less issues as they move forward. So the heat pump installation, what we're looking for really is code wise, what things I need to change to put a new system in. And then, as he said, the power change. So condenser, the unit outside of your home, there is going to be no difference between a 4-ton AC and a 4-ton heat pump in the electricity that goes to that unit. The difference is going to be in what goes to the air handler, so the part that is going to replace your furnace and coil. Many times, if the builder of the home has used that circuit dedicated for your furnace, we can upgrade that to a 220 circuit without having any extra work other than a breaker. If it is needed, most applications do not need us to upgrade wire size, so we can still do it with minimal cost and minimal work to your home. The only time we're really going to have to do a larger circuit, somewhere you would see the may need a panel upgrade, is if we're going to put in a supplemental heat. That would be a heat exchanger inside that unit that works off electricity, and that would be the backup in case you did not want to leave the furnace as the backup. But that happens rarely. So the likelihood of needing to do a massive electrical change for one of these products is very low. But again, your contractor will go over those with you as they are putting the project together. Michael gave you some numbers there about the cost change, the difference between a straight AC and a heat pump. And he said the difference is there about $2,000. In our experience with them, we're running underneath that in terms of the difference between a straight replacement and then going to a heat pump. Usually, equipment costs can range somewhere between $300 to $1,000 difference on the equipment, and then the cost of the electrical changes are really the only difference between the two. So I would not assume that you're going to see a massive difference between the cost of install or replacing your system and or installing a new heat pump. Um, and the one of the biggest things that we haven't talked about here at all is when you are replacing a system, if you're replacing your gas furnace with a new gas furnace today. Our area here requires them to be these new ultra low nitrous oxide emitting furnaces. While they are better for the environment, they are very finicky. They are hard to install, they're more expensive, and they're prone to many issues, including noise, that going back 3 or 4 times, we can finally get to dial in. But that means you've had to have a contractor back in your home that many times to make them what you were hoping for in the first place. So there are other benefits other than just environmental as well. I talked about electrical. When you are keeping the existing furnace, that we were replacing then with a heat pump condenser outside and a new evaporator coil in your attic. That's going to be the same refrigerant as you would if you're replacing a central air conditioning as well. So there is no difference in that aspect either. So most of the changes you're going to see or when you're changing a new air conditioner, you will see with changing a heat pump as well. There's not going to be much difference there. Um, you will see a little bit less efficiency if you do keep your central furnace because the new blowers on the indoor unit, what is moving the air through your home, they are more efficient to meet all the standards. So a package system, meaning the indoor and the outdoor together, are going to be your most efficient uh, cost of electricity from here on out. And when he was talking about the differences in energy efficiency, the basic equipment that you would be replacing a system with is going to be about 50 cents on the dollar to your air conditioning consumption. And that will be the same with the heat pump. But to get to something that's going to be what's going to meet these codes, you're going to be somewhere in the neighborhood of 65 to 70% more efficient in your summer usage. So when you take that off of your bill and you add in what you're going to spend a little bit extra in the winter to run a heat pump off of electricity, many of our customers are still seeing a net benefit to their overall electricity consumption, and that is wiping out their gas consumption completely with the unit. So it can be left if you would like it as a backup. Your installer is going to run that as second stage heat. So every time your heating comes on, it's going to run the heat pump. It would only be in the times when that is unable to sustain adding heat to your home that the gas furnace would then kick in to give you supplemental heat. Other than that, when you have a contractor out to look at your home, they're going to have the majority of this information on them. They're going to know what they're looking for, and they're going to be able to point you in the right direction and hopefully do right by you to make sure that the installation is the right thing for you. That is all I had. If you want to open it up to questions, we can absolutely do that now.
All right. So, our first question from our audience is it true that older homes with poor insulation won't have good results?
Older homes with poor insulation are going to have less efficiency no matter what with a heat pump or with a straight air conditioner. If we are losing your heat or air conditioning out of poor insulation or poor windows, it doesn't matter what type of unit you have, you're going to be less efficient than the next person.
Thank you. Our next question is, I've heard that it is a good idea to do this when your old system needs to be replaced. If you have a working system, should you still install a heat pump system?
So again, that's not a question I can answer for you. However, when you replace an air conditioning system and wait for it to break down, I can guarantee you it's not going to happen on a nice day like today. It's going to happen when it's 110 degrees outside or when it's 65 degrees outside. And in those times, you are waiting longer for a good contractor. When it's busy, and we're booked out longer. So being proactive in these is never a bad idea. So again, that is just up to personal preference on when the replacement is. But taking advantage of the rebates that are available right now, I mean, with what Glendale's doing there and what we just had one close through South Coast Air Quality Management District. The process was pretty easy. It is a little bit of more information that you need from your contractor, but the application went through very quickly, and they are receiving the funds here in the next couple of weeks.
Brett, would you have a recommendation for someone who has a functioning system, but it's getting older? Like, how old do you think the system, you should let the system get before you start thinking about proactively replacing it?
So nationwide, 10 to 15 years is the lifespan of an air conditioning system. If you ask the local gas company, they would say 12 years is the max they would like you to leave a heat exchanger in your home, because after time, the heat exchanger starts to expand and contract, and we start to get little micro fissures. As you were saying, that's when you would get the carbon monoxide into your home. In our climate, we're a little bit better off than most places. So, 15 years to 20 years is a very good life expectancy of a system. So if we're somewhere in that time, especially when we start to see the increases in repair costs, we see a blower motor go out, or we start to see capacitors being burnt out every year. Those are signs the system is going to go, and replacing it now is always better than replacing it in 2 years. With the changes in efficiency, with the changes in the local and state codes, and with the equipment, shipping and everything getting more expensive each year, every month you wait it means the system is a little bit more expensive. So doing it when it's on your mind and when you can take advantage of those rebates and when you don't have to wait for a month to get a new system in, then absolutely those are things to look for.
Great. So our next question is, you've been talking about central systems. Does the Glendale incentive also apply to mini splits? Please talk about the differences.
I can just say the policy only applies for centralized systems, but mini splits are a great option for a lot of people, and the incentives do apply for the mini split. So you can still get that like $1,000 per ton, um, and some of the other incentives for those smaller systems. Brett, do you want to add anything?
No, but a mini split system, we think of them as just one room supplemental heating and cooling. Like I want to cool my garage, so I'm going to put a mini split in it, or I got a room that doesn't cool down well, so I'm going to put that. But more and more people are going to mini splits as a whole house option. It is a standard everywhere outside the United States, but they don't have homes as big as us in most areas, so it's a little bit easier to adapt. But when you do have mini splits throughout the home, you have true zoning. If I want it 65 degrees in my bedroom, my kids want it 72, and another one is 74. They have that control to make it exactly the temperature they want in each space. The cost to replace a central system with a full mini split from your home is going to be significantly larger than replacing with just a standard heat pump with a whole house heat pump because there's a lot more work involved, but that money will come back to you eventually and reduce costs. We're talking about running an air conditioner, a very small one in individual rooms. And when no one is in the living room, it's not being used, which is different from what it is with a central air conditioning. So the cost, the recoup time on those will be very quick.
Great, thank you. Our next question is, will people have to replace their HVAC ducts, or will the heat pump use the existing ducts?
That's going to be the same thing whether it is a straight AC or a heat pump. Again, the blower motor is moving air through those ducts. So as long as your ducting was sized appropriately for the system that you have and that we haven't had some external force make them obsolete, rodents in the attic or somebody up there doing work and stepping on it, or just over time it disintegrating, no, we should not need to replace the ducting in a heat pump installation.
Thank you. Oh, sorry, Michael, did you have something to add? Okay, thanks. Okay, our next question is, what's the heat permit? What's the heat pump permitting process like in Glendale?
The heat pump permitting process is the exact same. So this is a mechanical permit. We are replacing a piece of equipment you already have in your home, and you do not need permission to have that again. The building and safety code is there to make sure that I, as the contractor, bring those things up to date. The safety codes. So it is a quick application with the city. We get that back within minutes, and then an inspector coming out upon completion. But it is the exact same as it would be replacing your air conditioning and furnace.
And I would just add, um, you know, getting permit is an extra step, but it really protects the homeowner to get a permit because then you know that it was done correctly. Otherwise, you're trusting the contractor and they may have made a mistake or they may have not been, fully diligent. And so if a contractor is pressuring you not to get a permit, that might be a sign to that, that they're not going to do the best job. So it's
And
it's probably worth the money as the homeowner to have that kind of insurance.
it is really not a whole lot of money, and you're absolutely correct on that. So, if we're going to talk about contractors who are a little less than above board, if no one is following them behind to make sure that those small details that matter a lot are taken care of properly, then most people are not going to do them. So as you said, having somebody outside of that contractor making sure that all the things that we did in your home are safe and safe to use for the next 25 years is a small price to pay. And again, the cost of a permit is not thousands of dollars. This is not replacing a kitchen. This is not putting a pool in your backyard. This is a few $100s to make sure that we are doing the right things with electrical and combustion and water in your attic and all these things that matter to your home.
All right. What's sort of a follow up to that is, if my central HVAC was not permitted, then I will need to get a new permit for a heat pump, right?
Most likely, yes. The times that we see essential air conditioning that was not permitted, because most homes, had some sort of provision for air conditioning. In Glendale, there are still a lot of homes that didn't have them when they were built, but when they were added on the first time, usually that was done. If not, the central furnace, because almost every home had it, or at least a gravity furnace, that was permitted with the building of the house. So the change in cost to put in the or to do the heat pump side of it will be minimal and no difference from again adding or replacing the air conditioning system.
All right, our next question is, some say heat pumps are noisier than traditional gas furnaces and AC units. Is this true?
For the 95% that is not true. So blower motors have gotten more efficient and more quiet. So the indoor portion of your system that is blowing the air through your home is going to be quieter than the old unit. And outdoor, again, we're running in cooling mode, you will see no difference in decibel level between a standard AC and a heat pump. Now, you will have that condenser running in the winter time. So outside, there will be more noise than you would have had in the winter. But again, it's no different from the heating season. So, no, I would say for the most part, they are not any noisier than standard air conditioning.
All right, our next question is, we hear that refrigerants are changing. Are the new ones as good?
They are changing. Um, it's not good or bad. They still use the same principle to remove or add heat from your home. They just do it with a different chemical makeup, and this one is more environmentally friendly. So no different, no, not better or worse, just different. And again, when you are replacing your central air conditioning with a new central air conditioner, you would be moving to that new refrigerant as well. So there is no difference between the two.
All right, we next have a couple of questions about cost. So, Brett, do you have a ballpark price range that these installations usually cost if we're talking about like the full recommended package replacement? And like what's usually the upfront installation cost?
I don't. To guess on something like that, the only thing I can guarantee you is that I'm going to be wrong. Every home has challenges. Every home has things that are going to make it, a little bit more or a little bit less expensive, or like got to do more electricity. I don't, or more wiring. I don't have to do it. So unfortunately, I don't have a good number there. I can tell you on average for Los Angeles County, replacement of a full central system. I believe the last I saw was somewhere in the mid-teens on average. So with the heat pump being just a little bit more than that, that's a good general place to start.
Right. And our second question is that you said that Michael said that the cost difference between using a heat pump and using a furnace isn't significant. Are there any estimates as to what the difference is?
There is. So, as part of doing the REACH code, there was a cost effectiveness study done, and they looked at different scenarios and they estimated the cost difference for your utility bill over the entire year. Um, and it ranged from about like $100 more to saving $50, something in that range. And that's over the course of an entire year. And so um, some of the scenarios it's actually cheaper. Some of the scenarios it was a little more expensive. It's um, yeah, so that's the range, I guess.
And every one of these units is going to have a coefficient of heating that your contractor should be able to show you. So along with SEER rating, which is the essentially the miles per gallon for your air conditioner side, the amount of electricity is going to cost you to run that. They're going to have a coefficient of heating. So this is going to show you what the same dollar would cost from the gas to heat pump. And many of them, especially when we're talking about ones that are going to qualify for these rebates, are very similar.
Okay, thank you. So our next question is that our my contractor told me that that the California CA Clean Tech rebate funds were depleted in the first quarter of 2025. Have they been refurbished?
They did go out. They are back. It's a program that they want to utilize. So the money comes in blocks. So don't get discouraged if it goes away. I believe it was gone for a month and a half at the beginning of the year when they put more money in. We're still working on those funds. So there is now, and I truly believe there will be pretty much constantly from here on out funds to help with the replacement cost of these.
And one of the good things about it, the way it works, is, you know, if you hire Brett, he'll apply for it and basically reserve it for you ahead of time before he does the work, right, Brett? So you kind
Yeah.
of know you're getting it. It's not like, oh, you told me it was going to be available and now it's gone. It's reserved for you.
Correct. When we reserve, while while there's funds available, it's not like an airplane where they're going to overbook this and hope somebody's okay with not getting it. The funds are reserved, and they will allow all of those projects to finish before they open that money back up. Because it does happen sometimes where, you know, the people don't do the project after it was reserved, so we see money go back in that was let back into the program, but that is not done until all reservations are completed.
And is this retroactive? If you've already installed it while it was out, is it retroactive?
As far as I understand, no, it is not.
Thank you. Our next question is, do you have suggestions on how to make sure your system is sized correctly? I have heard that oversizing makes the system less efficient.
Absolutely. So this is what you're hiring a contractor for, is to make sure we're putting the right size system for your home. There are generalizations, depending on where you live, between 400 square feet and 500 square feet per ton, is a pretty decent a way to look at it. But the contractor should be doing one of two things. They should be doing a manual J load calculation on your home. So this is looking at the insulatory values of the home, how big it is, which way it's facing. All those things are going to change how much heat a home gains, and then we would design based on that. Unfortunately, in California, it's a little hard to do because they want us to go off of the average temperature for our area, which would be 94 degrees in the summer. So any day under 94 degrees with that method, you're going to love the system. It's going to run a long period of time, pull out a lot of humidity, be very energy efficient, and keep you very comfortable. On a day when it's 105, you're going to be calling your contractor because the system was undersized. So what we do is look at a room by room load calculation, or manual D, to find out what my CFM, my volume of air I need for the house. And then each ton of air pushes 400 cubic feet per minute of air. So we do the calculations. Your house comes out to needing 1,210 CFM. A 3-ton system is the right size for you. Some things are going to change that. If you like to keep your house at 68 degrees, then we're going to go a larger system than I would with somebody who like to keep their house at 80 degrees, because we need more cooling capacity. But those are going to be done on an individual basis.
And Brett, what do you think about variable speed systems? Is that something that you're installing?
The majority of what we're installing right now. Everybody's conscious on energy consumption, and again, to meet all of these incentives, the majority of the equipment that meets them is variable speed equipment. So not only does that become more efficient for your home, but what it does allows us to put in a system that is a little bit larger than what is necessary, because it will always ramp itself down to the proper size. So if your home calculated out on a load to need 3.5 tons of air conditioning, but you like to keep it cool and you're in an area where it does get to be 115 degrees, we can put in the 5-ton system, and the majority of the summer it's going to run at 3.5 tons capacity. So you're not losing anything by going with a larger system like you would if you went with a single stage 5-ton system where it could only run at that high speed. This will allow you to have that in the times when you need it and run more efficient in the times when you don't. So yes, variable speed, it will be in the next 5 years the only thing you can get your hands on, I believe. It is that much more efficient, that much better, and that much more comfortable.
And a gas furnace does that only come in the single speed basic
It does
essential
not.
version?
You can get the blower motors in
Okay.
a variable speed. However, you can only get the gas consumption in our area in a 2 stage. So a high and a low speed for the amount of gas that's going into the unit.
Got it. Okay.
All right, our next question is: are heat pumps installed outdoors or indoors, and do they have the same size footprint? Would I lose any space inside my house?
Inside your house, no, it is going to go where your furnace is. And for the most part, the furnace and coil are going to be the same size as the heat pump air handler. Outside where your condenser is, that is going to be replaced as well. And no matter what, whether you go heat pump or air conditioner, those have gotten larger. Much technology or much of the technology benefits to make the equipment smaller has happened on the indoor. On the outdoor, we need a very large coil or radiator to be able to be as efficient as they want for these codes and for our area. So the footprint outside may get larger. However, many manufacturers have come up with using the technology from the mini splits, a unit that discharges out the side as opposed to out the top. So they're skinnier. They sit right up against the side of the house. They're going to be taller than your air conditioning, but they will take up less space in your backyard. And those are very quiet. So quiet you really need to walk up on them and see them moving to know that your air conditioning or heating is on.
So I've heard that some coolant types are being banned in the US and Canada. Are there any current cautions as to the coolant in heat pump systems?
No, the R454B or the R32 are the only two that any manufacturer in our area are using. So as long as you have a reputable contractor that is not using these things outside of their spec, then no, you are going to get one of those two refrigerants depending on the manufacturer.
And they're all safe in terms of like the day-to-day use. The big difference is the greenhouse gas impact, and the ones they're getting rid of um, have much worse greenhouse gas impact. So that's why they're phasing those out. And the greenhouse gas impact happens when they leak, if they are not properly disposed of, and they're not properly, sealed. Then it can leak into the atmosphere, and the older ones are really terrible for the climate, and the newer ones are just bad for the climate. They're still pretty bad, um, but it's kind of moving in that direction of less greenhouse gas impact.
All right, our next question is: does GWP require you to cap the gas line to qualify for the incentive? Can you keep the gas line for other appliances like your stove or water heater?
I do not believe that they do. Some of them, Tech Clean will require it, but they're requiring it to be capped where the furnace was. So that is the end of the gas line. That would not affect anything else in your house, water heater or range or anything like that. So yes, it does need to be capped, but just at the unit.
Yeah, that's my understanding. I think the what I saw today, the Glendale does want you to cap your gas for your the system, but it doesn't it's not your whole house.
Unless you are leaving your furnace in place, correct?
I'm not 100% sure on that. I think we need to get
Okay.
someone from GWP to confirm that.
Great. So, with mini splits, can you clarify how to manage obsolete ductwork safely and economically? And how to make sure that all purchased equipment really meets current and foreseeable regulations and requirements?
Okay, so on the equipment side, um, anything that's allowed to be sold in our area is going to meet these requirements. To meet the requirements for local codes to get the efficiencies, you're going to need an AHRI rating. So American Heating and Refrigerant Institute is a governing body that manages the efficiencies of every piece of equipment. So one manufacturer can't say that there is more efficient. If you get a 16 SEER 2 Lennox system compared to a 16 SEER 2 Rude or Ream system, they're going to cost the same to run. across the board. So as long as you have that, which you will need for these rebates, you will need to have your contractor give you the proper HRI for the system that's being installed. And I missed the beginning portion of the question about the ducting.
Um, when installing a mini split, can you clarify how to manage obsolete ductwork safely and
Got it.
economically?
That it's just gonna get taken out. So the ductwork that's up there for the most part is going to be some bit of flexible ducting, whether it was the newer style flexible that just gets bagged up and taken out, whether it was the fiberflex material, which again just gets cut up and bagged out. The only thing that is going to be any more expensive to remove than anything else would be ducting that still had asbestos wrap on it or complete asbestos. I would recommend having that taken out at time. It's just going to be better for the envelope of the house. And if you ever want to do anything down the road, you do not have to worry about that. Asbestos has a bad name and everybody's worried about the cost of it, but as long as it hasn't been tampered with much, then the average removal cost for asbestos ducting system is somewhere around $1,000. So it's not a huge proposition to get rid of that if you do have that in your home. But other than that, every other bit of duct work is just your contractor and a couple of trash bags.
All right. So we have a few more questions. If you have any additional questions, please send them to me now. We are on our last few. All right. So, keeping a gas furnace for supplemental heat was mentioned several times. Does that mean that a heat pump by itself may not be adequate to heat my home?
No. So heat pumps again are working in reverse. So if you think about this in the summer months, when it is 84 degrees out, it is very easy to cool your home down to a 77-degree temperature that you would like. When it's 115, your air conditioning is going to run longer and it's going to work harder to condition that space. So with a heat pump, an air conditioner working in reverse, we're going to see that in the opposite direction. The lower the temperature outside, the less heat there is, the less latent heat there is to bring from outside into your home. Now, as I said, all the technology is going to these. So the newer equipment, even stuff that 2 years old, is wildly different than its efficiencies. The mini split technology has allowed them to get down to 10 degrees without losing any more than 15% in their capacity. So there is less of a time now where a heat pump will be able to condition your home. And again, the other ways to, if you are worried about that, we can put in a heat strip. A heat strip is just a dead short electrical inside the unit, which would add heat in the times in the, max one time a year when the system was below its temperature. If you do leave the gas furnace as a supplemental heat, it is never going to kick on unless that unit gets down below its capacity, and then you would have the gas fired appliance working. It is not again, at the end of the day, the most efficient way to would be to replace the entire thing. But if you had a newer furnace, something that you weren't worried about replacing in the next coming, years, then leaving that is not a bad deal. When that furnace does go out, we still need a way to move air through your home. So that furnace would be replaced with a new e-furnace, essentially just a blower motor, or a better air handler at that time. So your costs will go up a little bit overall, replacing a system that way rather than doing it all at one time.
In a
Great.
place, let me just add, you know, we have such um, temperate weather here, you know? I mean, it gets pretty hot in the summer, but generally we're pretty blessed compared to other parts of the country. There's places where it's, really freezing. And so that's where maybe the supplemental makes more sense. Um, but they also make cold climate heat pumps that are specially made for those cold climates. And Northern Europe, heat pumps are very popular there. And obviously it gets very cold there. So this is really something where I don't think we would have to worry about, but other places might.
Yeah, not very much. And the other nice thing about the variable speed, as you were mentioning, is we're used to an air conditioner that we turn on and turn off when we need to be more comfortable. When you go to a variable speed system, you're going to learn that the most efficient way to run your home is to leave it at a temperature that's comfortable because, like cruise control in your car, once we've got to speed, then it's very little gas added to keep you at speed. So once you get your house to 77 degrees temperature, then a variable speed system is going to come on and run at a much lower capacity and continue to run, which means that instead of letting your house get down to 54 degrees at night and then, running that heater to get it back up to 78, we don't have to be uncomfortable through the night. We let the heat pump run, and you don't get to a point where that heat pump is overtaxed by having to having to add so much heat to your home. So with little small tweaks to our habits of running the air conditioner, most people see little to no difference in their ability to add heat to their home, even in the worst of temperatures for our climate.
All right, next we have a couple of ordinance questions. Will the new ordinance affect the cost and lead time for a new AC system, especially during a heat wave?
Well, this is, I mean, a good question for Brett. If someone came to you and their system had just broken, would it take longer to get a heat pump than it would to get an AC?
It would not. And probably 90% of the appointments we go on, we are giving a heat pump option as well as a straight AC system. Because again, the rebates are available because it's the right thing to do for the environment, and because you know many people aren't aware of the regulation changes. This will be mandatory across the state at some point. So we're doing our best to educate people up front beforehand. So if there is a lack of equipment, it's going to be a lack of equipment across the board, not specifically to heat pump. They're stocking these readily everywhere in our market.
All right. Where does the money for rebates come from? And will the ordinance be enforced if there is no money for rebates? And will the ordinance be enforced if I can't find a qualified installer?
Well, in terms of the money for rebates, so there's different sources. For Glendale Water and Power, it comes from the public benefit charge, which is mandated charge on the utility bill. And I believe about half of that money goes to directly to rebate, or sorry, to bill rebates for lower income people. And some of the money is used for these incentive programs. Glendale Water and Power has had incentive programs for a long time, and they've just made some tweaks to it to be more aligned with this policy and more generous for this. So there's an ongoing funding source for it. And that this question did come up during the city council meeting, and the Glendale Water Power representative said they're confident that there will be money for this. There is no provision to stop enforcement if the incentives go away. I think we've covered a lot of the reasons why it's still probably the right decision, even without the Glendale Water and Power incentives, and there's other incentives that are available. Um, City Council always has the opportunity, if it needs to change regulations. And so if there was a point in time where this policy did not make sense, the city council could revisit it and remove it at this time. But there's no automatic trigger to stop enforcement. And then, Brett, you can answer the question on the availability of people to install the systems.
So yeah, the difference between installing one of these heat pumps as opposed to an air conditioning is negligible. So just about any contractor out there should be able to navigate the differences. So finding a contractor that can install one of these is shouldn't be hard. You still want to do your due diligence, make sure that you find a partner that's going to do the right thing, make sure they ask you the right questions, put the right equipment in your home, and stand behind any of the warranties that are out there. But no, finding a contractor to be able to install even a variable speed heat pump should not be tough.
All right, so we have two more questions. I think we are going to wrap it up after those two questions. Thank you so much, everybody, for coming. So, our next question is, if you have an inactive gas furnace in line that you're not using and currently use plug in heaters, can you qualify for the incentive for a whole house heat pump HVAC system?
If all they
Um,
require is for you to be capping off a gas line, I don't see any detriment to that. I don't see any reason that would not qualify.
yeah, I believe that's the case as well. Yeah.
All right. So, our last question is, what is the best manufacturer and system that you would recommend to your best friend or your mom?
So I mean, I'm gonna have to get personal. Lennox is our manufacturer of choice. They are the last one that is majorly manufactured here in the United States. They have phenomenal warranties. They have all of the equipment bells and whistles that you would want out of a system, and their support is second to none. So a Lennox variable speed is what I have in my house. It is, what many contractors would want. Now, that's not to say that all of the manufacturers out there don't have equipment that will meet these regulations, and that installed installed impeccably will give you the same amount of years without any issue. But if I got to put a number out there, Lennox is the one.
Great. All right. Well, thank you, Michael and Brett. Thank you both so much for your time and for answering everyone's
Thank you, Emily.
questions. And to everyone who came, thank you guys so much. We hope that this helped educate you on the ordinance and about what you need to know to get a heat pump for your home. And yeah.
Thank you. This was a lot of fun.